Hello students, welcome back. So this is our lesson number 7 of the chapter Carbon and its compounds. So here our first topic is about isomerism. And I already explained to you earlier what isomerism means. So again I'm telling you, it means the compounds having same chemical formula but they have different structures. Right? Now see question number 1. Draw all the possible isomers of pentane and write their IUPAC and general names. So the pentane has the formula C5H12. Now we have to draw all the possible isomers and write their IUPAC and general names. See the first structure. As you can see, the carbons are arranged in a straight line. These carbons are in a linear way. So the general name is N-pentane, okay? And the IUPAC name is pentane. So this is your first isomer of pentane. Now see the second isomer of pentane. As you can see here that one methyl group is shifted to the second or the third position of carbon atom. So the general name is isopentane. And okay, here now select a straight chain having maximum carbon in it. Okay, so this is the chain having the maximum carbon in it. Now name the branch chain as an alkyl according to the number of carbons. Okay, so the IUPAC name is methyl butane. Clear everyone? Alright. Okay, now see this isomer of pentane. Here you can see that two methyl groups are shifted to the second position of carbon atom. Right? One is above and one is below. So the general name is neopentane. Here also select a straight chain having maximum carbon in it. So this is the straight line, a straight chain you can say. Here also name the branch chain as an alkyl according to the number of carbons. Okay, so the IUPAC name is dimethyl. So there are two methyl branches, so we put dimethyl as the name. Okay, therefore the name is dimethyl propane because there are 3 carbons in the straight chain, so the name becomes dimethyl propane. I hope you are clear now. So these are the 3 isomers of pentane. Next see IUPAC rules for nomenclature of carbon compounds. The IUPAC name of compound is obtained by writing the name of alkyl group just before the name of the parent hydrocarbon. So this is the first rule, okay? See one example, you will understand for better way. So this is your methyl propane, right? Since 3 carbon atoms are present, so the root word is propane. And a methyl group is present, so it is your methyl propane. Now see some more examples, okay? Let us now solve a few examples for IUPAC nomenclature using the rules discussed earlier. Now here the longest carbon chain has 3 carbon atoms. This is the longest carbon chain, so it has 3 carbon atoms. And the parent alkane is propane, right? So the functional group here is halo group, means here bromine is present. Since bromine is under the halogen group, so the functional group here is halo group. And the prefix is bromo. So the compound name will be your, write the parent alkane, that is propane, and write the prefix before the parent alkane. So that will be your bromopropane, right? Now see the second example. In this structure, the longest carbon chain has 4 carbon atoms, right? This is the longest carbon chain. Here the parent alkane is butane. And now see the functional group present here, OH. That means alcohol. So the suffix is OL. Now write a compound name. It will be butanol. Am I right? Okay. Now see the third example. Here also the longest carbon chain has 4 carbon atoms. And the parent alkane is butane. But here the functional group present is alkene. That means the double bond is present, as you can see here. So the suffix is ene. Now write the compound name. First the parent alkane, it is butane. Now add the suffix. So it is your butene. So this compound is your butene. Clear everyone? See the fourth example. Here the longest carbon chain has 6 carbon atoms. Alright, so this is the longest carbon chain. It has 6 carbon atoms. And the parent alkane here is again, here the parent alkane is hexane. Right? And the functional group present here is halo group. This chlorine is present, so it is halo group. And the prefix we will use chloro. So the compound name will be chlorohexane. Right? See this fifth example. Here the longest carbon chain. Okay. So this way also it is the longest carbon chain. It has 5 carbon atoms. And if we say this and if we see this way, it has also again 5 carbon atoms. And in this way also it has 5 carbon atoms. So it is the longest carbon chain has 5 carbon atoms. And the parent alkane is pentane. So the functional group present here is alkyl group. Okay? And the suffix is ethyl. So write a compound name now. So first write a parent alkane, that is pentane, and add the suffix. So it will be your, it should be prefix. My bad. So it is your ethyl pentane. Okay? See the last example. Since there is only one carbon atom in a structure, we don't mention the position. Okay? There is only one carbon atom. So we don't have to mention the position. So the longest carbon chain here is 1. And the parent alkane is methane. And the functional group present here is carboxylic acid. So the suffix is oic acid. Now write the compound name. First write the parent alkane, that is methane, add the suffix here. So it is your methanoic acid. Okay guys, so our next topic is about homologous series. Alkane, and it has the general formula CnH2n plus 2. Now make a table, and in the first column write the values of N, the molecular formula, name of the compound, the molecular mass and difference mass. Now put the value for N equal to 1 in the formula, so we will get the molecular formula CH4. So the compound name is methane. Now molecular mass means we have to add the atomic masses. So now find out the molecular mass of methane. So it is 12 into 1. 12, it is the molecular mass for carbon. Since there is only one carbon atom, so it is multiplied with 1. Plus 1 into 4. So 1, it is the molecular mass of hydrogen. And since there are 4 hydrogen atoms, so it is multiplied with 4. So 16 is the molecular mass of methane. Similarly, N equal to 2, we will get the molecular formula C2H6, and that is ethane. And the molecular mass of ethane is 30. So similarly, we will find the molecular formula for propane and butane and their molecular weight. Now how to find the difference in weight? So calculate the difference in weight between two consecutive, that is one after another members. Alright, so see here, we will subtract 16 from 30. So we will get 14. And then again we will subtract 44 from 58. So we will get 14. Now what can you see? The molecular weight of consecutive members always differs by 14 units. Right? So the consecutive members even differ by CH2 group. See this, that is methylene group. Let's take an example of methane and ethane. C2H6 minus CH4, so we will get CH2, right? Here we will get CH2 and CH2. Okay, see this. Next is alcohol. Let us study one more example. Okay, a group of organic compounds having functional group OH. Okay, see the general representation of alcohol. ROH. R is the alkyl group and OH is the functional group. And the general formula is CnH2n plus 1 and add the suffix OH. So first name of the compound, the methyl alcohol. Here the molecular formula is CH3OH. Second is ethyl alcohol and the molecular formula is C2H5OH. Okay. And it is propyl alcohol C3H7OH and butyl alcohol C4H9OH. Now see here, these two differ by CH2 units, right? As you can see, it is differ by CH2 units. And between these two, it is also differ by CH2 units only. Now see homologous series. So here name of the compounds given and this side the molecular formula. First is methyl alcohol CH3OH, then ethyl alcohol C2H5OH, then propyl alcohol C3H7OH, and lastly butyl alcohol C4H9OH. Now can we call this as a group of compounds? Yes, we can call them. So see, a group of organic compounds containing same functional group. Now what is the functional group here? The functional group here is OH. So a group of organic compounds containing same functional group, in this case that is OH, which can be represented by same general formula. Here also it is represented by same general formula, right? Now what is the general formula? The general formula is CnH2n plus 1 OH, and which more or less so similar trends in their properties is known as. Now what are the similar trends in their properties? The physical and chemical properties of the compounds show a gradual change. Okay, so it is known as homologous series. Now see the characteristics of homologous series. First one is all the members have same general formula. Second point is they have same functional group. Third is they have similar chemical properties. And the fourth is physical properties like melting point, boiling point, density, so a gradual change with increase in the molecular formula. And the fifth is consecutive members of the series differ by CH2 group, that is methylene group, and their molecular weight differs by 14 units. Now write the molecular formula of the third and fifth members of homologous series of carbon compounds represented by the general formula CnH2n-2. Okay, now this is the general formula of alkyne, right? Now since methane does not exist, so the solution, see, the third member will have 4 carbons Similarly, fifth member will have 6 carbons. So let's see. Therefore, substituting the values in C and H2 and -2, the third member will be butane, that is C4H6, and fifth member will be hexane, C6H10.